Welcome to the AI Mastery course, which is part of the AI Engineering Bootcamp. Hi, I am Vivian Arana, and I'm going to walk you through this course. First, before getting into the course, let's understand some of the AI concepts. And what better way to understand AI concepts than through food? So, let me give you an introduction to artificial intelligence. Artificial intelligence, AI, is like learning how to cook. Just as cooking transforms raw ingredients into delicious meals, AI transforms raw data into useful insights and actions. Let's explore the world of AI through the lens of food and cooking. First, let's look at some of the fundamental AI concepts. Data. Data is like ingredients in your kitchen. Just as a chef needs quality ingredients to create a great dish, AI systems need quality data to produce good results. The fresher and better your tomatoes, the tastier your sauce. Similarly, the cleaner and more relevant your data, the better your AI's performance. Algorithms. Algorithms are like recipes. They are step by step instructions that tell the computer how to process data to achieve a specific outcome. Just as different recipes produce different dishes from the same ingredients, different algorithms can produce different results from the same data. Machine learning. Machine learning is like learning to cook without explicit recipes. Instead of following precise instructions, you observe many examples of successful dishes and learn patterns. After seeing hundreds of properly cooked steaks, you learn to recognize when a steak is done by its appearance and texture, not by strictly following cooking times. Neural networks. Neural networks are like a complex kitchen with many specialized stations. Each station, or also called as neuron, performs a simple task, but together they can create sophisticated dishes. The prep station chops the vegetables, the grill station cooks the meat, the sauce station prepares sauces, and together they create a complete meal. Similarly, neural networks have layers of neurons that each perform simple calculations, but together can recognize faces or translate languages. Deep learning. Deep learning is like having multiple kitchens stacked on top of each other. The output of one kitchen becomes the input for the next. The first kitchen might prepare basic ingredients. The second kitchen combines them into components, and the third assembles the final dish. With each additional kitchen, or let's say layer, more complex dishes, or let's say AI tasks, become possible. Let's dive into types of machine learning. We have three different types. First one is supervised learning. Supervised learning is like cooking with the master chef watching over you. The chef or supervisor shows you exactly what the dish should look like, in this case, label data, and gives you feedback as you cook. You learn by comparing your results to the ideal outcome. For example, you're shown pictures of perfectly baked cookies alongside their exact recipes and baking times. Next, we have unsupervised learning. Unsupervised learning is like being given pantry full of ingredients without recipes. You need to figure out which ingredients go well together by experimenting. You might discover that tomatoes, basil, and mozzarella make a nice combination, creating categories of ingredients that work well together. AI does this by finding patterns and grouping similar data without being told what to look for. Next, we have reinforcement learning. Reinforcement learning is like learning to cook through taste testing. You try different approaches to make a dish, and when it tastes good, which is positive reward, you remember what you did. When it tastes bad, which is negative reward, you avoid those methods in the future. Over time, you optimize your cooking through trial, error, and feedback. That covers our types of machine learning. Let's talk about AI techniques and applications. First, natural language processing or NLP. NLP is like understanding food description in different languages. It's about teaching computers to understand human language, just as global chef needs to understand food terminology across cultures. When someone asks for eggplant in America or aubergine in UK, the chef knows they are referring to the same ingredient. Computer vision. Computer vision is like a chef's trained eye. An experienced chef can look at the dish and immediately identify ingredients, cooking techniques used, and even spot if something is undercooked. Similarly, computer vision allows AI to see and interpret the visual world, recognizing objects, people, and activities in images and videos. Generative AI. Generative AI is like a chef who can invent new recipes. After learning from thousands of existing recipes, this chef can create entirely new dishes that have never existed before but still taste delicious and make culinary sense. Generative AI creates new content, text, images, or music based on patterns it has learned. Large language models or LLMs. LLMs are like master chefs who have memorized every cookbook ever written. They have absorbed so much knowledge about cooking that they can discuss any culinary topic, answer questions about obscure ingredients, suggest substitutions, and even write new recipes in the style of a famous chef. LLMs like GPT-4 have been trained on vast amounts of text to generate human like responses to prompts. Next, let's look at some of the AI architecture components. First, we have the training data. Training data is like the cooking school curriculum. It's the collection of examples that an AI learns from. Just as student chefs practice by cooking many dishes, AI systems improve by processing many examples. The more diverse and representative the training dishes, the more versatile the chef becomes. Features. Features are like the characteristics you notice in ingredients. A chef pays attention to the ripeness of fruit, the marbling in meat, or the aroma of spices. These observable properties help make decisions. In AI, features are the measurable properties of data that algorithms use to make predictions. Model. A model is like a chef's developed intuition and skill set. After training, a chef develops an internal understanding of cooking that guides future decisions. Similarly, an AI model is the result of training algorithms on data, capturing patterns that can be applied to new situations. Inference. Inference is like cooking a meal after you have mastered the techniques. Once a chef has learned how to make pasta, they can prepare it without referring to a recipe. Similarly, once an AI model is trained, it can make predictions on new data without having to be retrained. Let's move on to advanced AI concepts. First, let's talk about overfitting. Overfitting is like memorizing a recipe so exactly that you can't adapt to different kitchens. So, let's say you have learned to make chocolate chip cookies in your home oven at a specific temperature for exactly 9 minutes. But in a different oven or at different altitude, this rigid approach fails. An overfitted AI model performs well on training data but poorly on new data. Underfitting. Underfitting is like learning only the basics of cooking without mastering any specific dish. You know you need to heat to cook food, but you haven't learned the nuances of temperature control for different ingredients. Your cooking is consistently mediocre because your approach is too simplistic. An underfitted AI model is too simple to capture the underlying patterns in the data. Bias in AI. Bias in AI is like a chef who has only ever cooked one cuisine. If you have only ever made Italian food, you might incorrectly apply Italian cooking techniques to Japanese dishes. Similarly, if AI is trained primarily on data from one demographic group, it may perform poorly for others. Explainable AI or XAI. Explainable AI is like a chef who can describe exactly why they made each decision. Instead of just serving a delicious meal, they can explain why they choose certain ingredients, cooking temperatures, and techniques. XAI aims to make AI decision making transparent and understandable to humans. Transfer learning. Transfer learning is like a pastry chef switching to bread baking. Many skills transfer, like understanding dough, controlling oven temperature, etc. The chef doesn't start from scratch but adapts existing knowledge to a new domain. Similarly, transfer learning allows AI models trained on one task to be repurposed for a related task with less training data. Let's look at AI ethics and considerations. First thing that we always consider is privacy concerns. Privacy in AI is like respecting secret family recipes. Just as you wouldn't share someone's treasured family recipe without permission, AI systems must handle personal data with appropriate protections and consent. Ethical AI. Ethical AI is like sustainable cooking practices. Just as responsible chefs consider the environmental and social impact of their ingredient sourcing and waste management, ethical AI development considers the broader implications of AI systems on society, fairness, and human welfare. AI safety. AI safety is like kitchen safety protocols. Chefs implement measures to prevent accidents with sharp knives and hot surfaces. Similarly, AI safety involves designing systems with safeguards to prevent unintended harmful consequences. Let's look at some of the emerging AI trends next. We have federated learning. Federated learning is like chefs improving recipes without sharing their exact ingredients. Multiple restaurants collaborate to create better dishes, but instead of revealing their secret ingredients, they just share how their modifications affected taste. Federated learning allows AI models to be trained across multiple devices without sharing the raw data. Edge AI. Edge AI is like cooking at the table rather than in a distant kitchen. Instead of preparing food far away and delivering it, potentially cold, you cook right where it's needed. Edge AI processes data locally on devices rather than sending everything to distant servers, reducing latency and privacy concerns. AI augmentation. AI augmentation is like having a smart kitchen assistant. The assistant doesn't replace the chef but enhances their capabilities by suggesting ingredient pairings, monitoring cooking temperatures, and handling repetitive tasks. AI augmentation aims to enhance human capabilities rather than replace them. Quantum machine learning. Quantum machine learning is like discovering entirely new cooking methods beyond conventional heat. Traditional cooking uses heat to transform food. But what if we could use other physical phenomena? Quantum computing applies quantum mechanical principles to potentially solve certain problems exponentially faster than classical computers. Just as the culinary world ranges from simple home cooking to molecular gastronomy, AI spans from basic rule based systems to cutting edge neural networks. Understanding these concepts through familiar food analogies helps demystifying this powerful technology. Now, whether you're a chef or a diner, a developer or a user, appreciating the ingredients, recipes, and techniques of AI helps us all make better use of these powerful tools in our daily lives. With that, let's get started. If you're not yet enrolled in the AI Mastery course, I would say get started with the AI Mastery course where we will go through all these different topics and try to master AI and use in our day to day lives. So let's get cooking.